How's it going, everybody? And I'd like to welcome you back to our MPLS Layer 3 VPN section. And I want to spend a little bit of time initially in this video to talk about some of the optimizations and enhancements we can use with some of the routing protocols that we have available to us. I first want to start off with the first two bullet item options up here that we have, which is BGP AS path manipulation, and then we're going to talk about P to C site of origin. We're going to focus more or less on the site of origin in upcoming videos where we'll actually go through the configuration of them, but I want to focus on the AS path manipulation first because that's going to be something that is more than likely immediately going to be a problem for a lot of organizations that I could see a lot of you working with, and I'm talking from firsthand experience myself. So the first thing that we need to understand about how BGP AS path manipulation works and how it'll come into play in an MPLS Layer 3 VPN environment is tied back to when you have multiple sites that you have tied to an MPLS Layer 3 VPN service. Now over here we have AS10, over here we have AS15, and for the most part those routes have been able to propagate relatively easily. We haven't had many problems with any of the propagation because of the fact that we're going from one AS to another AS, and we don't have any of the AS path, any of the eBGP path loop prevention mechanisms in play. So let's talk about that for just a minute. So what do I mean by the AS path loop prevention? Well, whenever a route is propagated by an BGP speaker, for example here on R15, if R15 has a route and he propagates that to CSR6, CSR6 is going to learn that prefix, and inside of learning that prefix, the origin AS, or the AS where that route was originated from, is going to be AS15, which we can see right here. Now, what's going to happen is CSR6 is going to learn that as AS15 from R15, and then CSR6 will propagate that to 4 and to XRV10, and then propagate that to all of the PE routers. The PE routers will then learn that and then propagate that down to their associated customer edge routers. Now, what's going to end up happening is R13 and R14 are going to receive those routes as anything from R15 is going to look like it's coming from AS15, which is what you would expect it to see or show up as. Then one of the intermediate ASs, so an AS in the transit path between you and wherever the route was originated from, is going to be an AS hop along the way. So all of these routers inside of AS100 are going to appear as one AS hop, but there could be potentially 100 routers in an autonomous system, or even multiple hundreds, or if not thousands or tens of thousands of routers, depending on how large the service provider is. Now, in the event that you get to a situation where you have a customer that attaches to a service provider providing MPLS Layer 3 VPN service, and that service provider or that customer decides to use the exact same autonomous system on every one of its sites, that can be a bad thing. So what I'm going to go ahead and do is I'm going to talk about how that can come into play. So what I'm going to go do is I'm going to, on R15, I'm going to go ahead and pull up this connection. So I'm going to go ahead and pull this up. So on R15, I'm going to do a quick show run section, pipe include router, and I'm going to go ahead and see whatever's configured for this setup. So right now there is no routing configuration. If we do a show IP route, it's probably just a default route, which it is. Now, what I'm going to go do is on CSR6, I'm going to go in here and show run section BGP. And underneath the IPv4 VRFC1 of router BGP 100, I'm actually going to come in here and type in, first and foremost, no redistribute static and no neighbor of 106. I'm going to eliminate that neighbor adjacency. Now, the adjacency doesn't actually exist because router 15 isn't running any autonomous system. I'm also going to go to the no redistribute static for IPv6, and pull this neighbor statement out as well. So what will end up happening is on CSR6, we will be basically a blank canvas for our next setup. So what I'm going to go do is I'm going to configure R15 to peer back to CSR6, and what I'm going to go do is I'm going to make it look like 15 is coming from 10. So essentially I'm just going to make R15, I'm going to say router BGP 10, so that it matches these routers over here. There are some other BGP modifications that you can use, and I'll show you what they are, and we'll take a look at those in upcoming videos, because that might come into play in your deployment. So in R15, if I was to go to global config and type in router BGP 10 and type in BGP, and I was to swap out the BGP command is, I actually don't know, I think it might be an AS address family IPv4 unicast, and then there would be a BGP. You would swap out, is it the best path? I actually would have to go look it up. I don't remember off the top of my head what the command is. I think it's best path. Best path, no, it is not that. It's BGP, and it is, there's a command in here. I'll have to go look it up. I don't want to waste much more time than this, but best path, yeah, it's not in here, and at least it's not jumping out at me immediately. But basically what you would do is R15 can be still configured as 15, but you would make it look like it's coming from 10, something along those lines. But I'm not going to worry about that right now. If we configure the peering, we're in AS10 is what we set it up to be, router BGP 10. So I'm going to type in no BGP default IPv4, and I'll type in neighbor of 101.6.15.6, remote AS of 100, and then I'll type in address family IPv4, and then the network of, and this will be 10.1.15.0 with a /24 mask. And then that will go, and then I'm going to go back to CSR6, and I will go back to the IPv4 address family, and I'll type in neighbor of 101.6.15.6 remote, or sorry, 15 remote AS of 10. Okay, so what will end up happening is this adjacency will come online, and the routes will be learned, and the routes will get propagated. The other thing that I want to just double check on is making sure that the connection on CSR1 is BGP, so do show run section BGP. Make sure that I have my peering ready to go, and I do not, so I have to go underneath router BGP 100, address family IPv4 BRFC1, and type in neighbor of 101.1.13.13, remote AS of 10. So let's see, CSR6 should have popped up by now. R15, do show IP, do ping 101.6.15.6. Okay, that works. CSR6, do show run section BGP. So that is configured correctly. Not sure why it's not forming. Show run section BGP. A little bit of troubleshooting here. That's okay. Sometimes it's needed. Yeah, 101.6.15.6. And then advertise, so show BGP IPv4 unicast summary. Nothing. Okay. Why is that not working? That's all squared away. We'll do a show run interface gig 3. Okay. Show run interface gig 3.101. we go in and get rid of this guy right here so we don't have any problems there. So 15, for whatever reason, is not forming the peering. Let's see if 6 is configured correctly. 6 should be configured correctly, remote AS 10. And he is. Show run VRF. The VRF is configured. Let's turn some of these, get rid of some of these routes. So let's go ahead and get rid of this IPv6 route as well. Get rid of that. That shouldn't affect the BGP peering though. So why is that not forming? CSR6 is configured. Show BGP and 615 to 50. Yeah, it's weird right now. It's not wanting to peer. What I will do is I will actually just do a quick write mem. And sometimes I've seen this happen before, and where show IP interface brief, where you have to do a reload, and it happens. So I'm just going to reload the box. But basically, what should end up happening is 15 will peer with CSR6. CSR6 will peer with 15. 15 will advertise its routes, but it'll come from the autonomous system of 10. That information will get passed up to CSR1, CSR32, and then XRV9. And what will end up happening is the routes won't get injected, or I'm sorry, they'll be advertised to the CE, but the CE will drop them. And the reason the CE will drop them is because the fact that they appear as though they're coming from their own autonomous system. So router 14 would receive the route and be like, well, why would I accept a route from an autonomous system I'm already a part of? I should know that through IGP, not through BGP. So because R14 would see a route coming from sourcing from AS10 as an iBGP route, and it would drop it. So what you'll end up having to do is actually stop that capability and allow the route to come through. There's a couple ways that you could do that. So, and I want to get it to the point where we can actually demonstrate that. So let's go take a look at CSR1. Let's go take a look at R13 real quick. And we'll do a show run section BGP. I might have to configure BGP here. I think it might already be done. So it's not. We'll type in router BGP 10, no BGP default IPv4. Neighbor of 101.1.13.1, remote AS of 100, address family IPv4. You know what, did I activate it? I don't think I activated it, now that I'm thinking about it. Was I a dork and did not activate it? Let's give that a second. Let me go finish the one on CSR1 first. So CSR1's been activated. R13. Yeah, that's what it was. Network. Let's check R15. Yeah, okay. So I was not very smart. I created my own problem. So let's go to global config, and it had absolutely nothing to do with the configuration. So I just rebooted for nothing. We're going to go ahead and activate the adjacency, and the adjacency should pop up here just momentarily. And that was my stupidity, but that's okay. I'm glad you guys got to see it, so you can not make that mistake yourself. So the next step would be to go back over to CSR1, and on R13, the adjacency is up. Let's type in network of 10.1.13.0, mask of /24. And then let me go to XRV9 and make sure that his peering to R14 is up. So do a quick show run router BGP. And we have to go to this peering here. So he should be there is not a neighbor configuration, so I will have to go in and create one. So let's go to router BGP 100 VRFC1, and we're going to go underneath address family IPv4 unicast, and I'm going to start yanking some of these commands out. Redistribute static, nope. Let's go, and actually let me bring this up to the top a little bit higher so we have more room to work with. We will remove that one, we'll remove this one. So I'm cleaning up the config from previous labs that you guys all saw, and we'll go ahead and do all this. And then I'm actually going to exit out of that, type in neighbor of 101.9.14.14, remote AS of 10, address family IPv4 unicast, and we're going to type in route-policy of pass in and pass out. Now I'm going to jump out of here a couple times and then go back to address family IPv6 unicast and dump that in there, pull this out. And I want to just clean this up as quickly as I can because it'll make it cleaner down the road when we go to do other things. And I'm going to go ahead and commit that config as well. So what we're going to have, and I'm glad you guys are seeing me do all this because this is pretty much what I would be doing if I hadn't already started the recording. So now if we do show run router BGP, the BGP config is like this, which is squared away. I'm going to go to R14 now, show run pipe include router to see if there's anything configured, and if there shouldn't be, but if there is, we'll go ahead and handle that. And then we'll type in router BGP 10, no BGP default IPv4, and then neighbor of 101.9.14.9, remote AS of 100, address family IPv4, activate the adjacency, and then type in the network of 10.1.14.0 mask /24. So now the adjacency is up, right? Everything at this point should be, we should have BGP peerings to everybody, right? Now if I jump out of here and do a show BGP, if I show BGP IPv4 unicast summary, we have a peering, but you'll notice that we're not learning any routes. But if I was to go take a look, let me bring this down now. If I was to look at, say, CSR4, who is a route reflector, show BGP VPNB4 unicast all summary, we're going to be learning routes from router CSR1, CSR6, and XRB9. I'm going to be learning all three prefixes, one from each provider edge. Now the question is why am I learning these routes but I'm not propagating them? Well, the answer is because when I go to R13 and I jump out of global config and I do a debug BGP IPv4 unicast updates inbound and I clear IP BGP star soft in, what we're going to run into, give that a second to do its thing, you'll notice that for the 10.1.14 network and the 10.1.15 network, it's denied due to AS path contains our own AS. And so what's going to end up happening is we're going to not accept the route because it looks like it's an iBGP update, and by default we're not going to do that. We're going to deny that. So we're going to go ahead and block that. So there's two ways you can fix this. On iOS, you can do an iOS XR as well. You can do this on both. You can go on router BGP, router BGP 10, and then you can type in address family IPv4 and type in neighbor of 101.1.13.1 allow AS in. And then you can specify the number of recurrences of the autonomous system number. I'm just going to hit the enter key. And then what will end up happening is you'll notice that the update comes through, and you'll notice that this is the actual path, 110. So if I come in here and do show BGP IPv4 unicast and hit the enter key, you'll notice that now I have all three prefixes in the routing or in the BGP table. The AS path from where it was originated, it had to go through AS100, so that's who I'm directly peered to. And this route right here was propagated inside of AS10. Now, that's how you do it on the provider side, or the customer side. On the provider side, it's a little bit different. If I go to R15 and I look at the show BGP IPv4 unicast, I'm only advertising my route. Now on CSR6, I can go to router BGP 100 address family IPv4 VRFC1 and type in neighbor of 101.6.15.15 and type in the command is near the top here called AS override. I can say that, and I can do split horizon, but I'm not going to focus on that right now. I'm going to do that and hit the enter key. And so as soon as I do that, once it clears, and it does its thing, if I go to CSR6 and I do clear BGP IPv4 unicast star soft, I go back to R15, I hit the up arrow. What it should do is summary. I am peer, but I'm not learning any routes. If I do a clear BGP IPv4 unicast star soft, now I have the routes learned. But you'll notice that it looks like it's coming from AS path 100 twice. What's actually being done here is this is the original, this is the origin AS, so this is where the route was originally sent from. It's swapping out 10 for 100, saying, you know what, let's not send the route making it look like it came from AS10. Let's make it look like the service provider advertised it to us, not the client attached to the service provider. So there's that. Now, if we go down to R14 here, we hit the up arrow, we can see that still nothing is happening. So XR is a little bit different. XR, even if I was to go on here and type in router BGP 10 neighbor of, or I should say address family IPv4 neighbor of 101.9.14.9 and type in allow ASN and do clear BGP IPv4 unicast star soft, do show BGP IPv4 unicast. Even if I do that, it still doesn't affect anything on R14. R14 doesn't care because XR is smart enough to know that if I send a route down to you, then if I look at my BGP table, if I do a show BGP VPN-v4 unicast, I can see that the original AS path is 10. I'm not going to send it out to you even though you have constructed it. So if I was to go ahead and do this from XR, we do a debug BGP update for VRFC1 for in the outbound or the AFI of IPv4 unicast in the outbound direction. And if we were to do a clear BGP VRFC1 IPv4 unicast and do a star soft in the outbound direction, what should happen is, let's take a look at the outputs here, is it shouldn't make a difference how we do it, because right here it says not advertising to sender AS10. So it detected that from both. It says not sending to this guy here. And the reason why it's not going to is because it can detect that it's sending it to a neighbor of 10 from a source of 10. It's like, well, I can't do that, guys. It's not going to make any sense. Why would I send that? XR is smarter than that. So what I can go do is I can go to config t router BGP 100 vrfc1 neighbor of 101.9.14.14 and type in address family IPv4 unicast and type in AS override, and then I can commit this command, and what will end up happening is it will go ahead and it should send the update out now. Notice how it's sending it? It's going to send everything. Sending update outbound, and there's no restriction now. It's saying, okay, fine. And I'm looking for it now, and I don't see it showing up at the moment. So process update goes out. And it doesn't show that it's swapping out the autonomous system number. At least I don't see it showing up in the debug anyway. If I go over to R14, I hit the up arrow, now I get the routes. And it's coming through as 100 and 100 again. So that's how AS path manipulation works. That's how you would associate that particular attribute and that particular capability. So that's AS path manipulation with allow AS in and then AS override on both the provider and the customer. The customer side is allow AS in, the provider side is going to be AS override. And that is how you would handle that. There are other things when it comes to route feedback that we're going to talk about in P2C routing with site of origin in an upcoming video. But that is basically what you need to know in terms of how all of this stuff comes together. Until next time, guys, thanks so much for stopping by and hanging out with me in this video. Until next time, take it easy.